we will have the second and the last assessment. It's called the derivatives assessment. Let me show you where it is. Go to modules and scroll down to skills and derivatives assessment. And you have the upload. It's due next Tuesday, not Monday, but Tuesday night before we meet on Wednesday, please. This is created by the math department and we have to do it, please. So scroll down. My computer is still going in circles, I'm sure. Yeah, a little bit. Almost there. So if you scroll down after the video lectures and lecture notes for fall 2023, you will see a folder with skills assessment and derivatives assessment and the upload. Okay, here it is. So derivatives assessment, upload, and you have derivatives assessment file. Everything is here. You either click here and you'll see the file, or you click here and see the file, one or the other. And it's 30 points, and it's part of the skills and derivatives assessment. And please, you have 10 questions there, 3 points per question. You only have to differentiate. Okay, so if we can simplify, please simplify. If it's something like I'm going to show you right now on this problem, you can simplify. Okay, so let's go back. So please finish it up, start working on it as soon as possible so you can ask questions Wednesday and Monday. It's due Tuesday. So if you need any help with it, I'll help you with similar problems. But you have to look at it quickly. It's 10 questions. Okay, so
is that something, I'm sorry.
Go ahead. No.
Is that similar to that very first one that we had to do where
No,
like
that's not in WebAssign. That's not in WebAssign. No. It's a document, a two-page document.
But we'll upload like pictures of our work.
Yes, but you don't have to use the template. But those are the problems. Yes. So you can write them on blank sheets of paper. You don't have to use the template.
Okay.
Very good. So let's differentiate. So remember, we start from the outer function. So power 3, which has to go down. Sine squared e to 2x to the third. I only differentiated this. Now I have to differentiate the inner function, which is cosine of e to 2x to the third. Now I have to differentiate the inner function, which is e to 2x to the third, times the innermost function, which is 6x squared. And this is it. Yes, I will rearrange it by multiplying 6x squared by 3, so I have 18x squared, and then copy these 3. So e to x to the 2x to the third, and times sine squared of e to 2x to the third, and then times cosine of e to 2x to the third. Okay. So now we continue with 3.5. So 3.5 deals with something called implicit differentiation. What is this? What does implicit mean? Okay, so if I'm given the function f of x equals 3x squared, this is given directly. It's the function. I'm given the function. In order to find the derivative, I will differentiate and get 6x. But what if I have something like this? Tangent y plus 3x squared y to the fourth equals 2x to the fourth. So I'm given this equation. No one can solve this equation for y. No one. No human being can do that. So I can still find the derivative of y. Y is the function, of course. But y is given to us implicitly. It's given to us in a roundabout way. In other words, it's given to us in a form of an equation. So it's inside that equation, but I cannot solve for y. Here I was given y directly. Y was 3x squared, find f prime. Okay, 6x. So here I'm given y, but inside an equation, and I cannot solve for y. That's why for this, moving forward in implicit differentiator, we will not use this notation. Nothing wrong with it. We will be using this notation. So we are given this equation, and we are asked to find dy over dx. Well, like in many, many, many other situations, in this case, I have to differentiate both sides. When I solve the equation, the square root of x equals 2, I square, because I'm applying the inverse operation, or I'm applying the same operation to both sides no matter what. Same thing here. I'm allowed to apply this procedure, this operator, to both sides. And I have to be careful that y is a function of x. What I suggest to my students is, just to make sure you don't forget, put a little dot under y. That will say basically, caution, caution, y is a function of x. So let's start by differentiating. Can anyone differentiate tangent of a function for us? Tangent of a function.
Would that be secant squared of that function?
Secant squared y times the inner function prime. We have to learn those few words. Times the inner function prime. So what is the inner function prime? You can say I don't have it. Yes, but I have to use a symbol then. How do I write the inner function prime?
Y prime. Oh, dy over.
You're correct. Y prime is correct, is the correct answer. But we're not going to use that notation. We're going to use this notation. But that's the correct answer. Plus, can anyone differentiate or tell us, first of all, what rule applies here?
Would that be the product rule?
Excellent. So I have to differentiate the first function. When I differentiate the first function, what do I get?
6x.
Yes. So I have 6x times y to the fourth plus. I copy the first function, and I have to differentiate the second function. Let's differentiate the second function.
That's 4y cubed.
4y to the third times the inner function prime times the inner function prime. How do I write times the inner function prime?
Yeah.
How do I write times the inner function prime?
Dx over dy. I mean dy over dx.
Excellent. Equals. Can anyone differentiate this for us?
8x over cubed.
Excellent. Okay, notice now what happens. From this point on is only algebra. No more calculus for this problem. So first of all, I have to realize that the factor or the variable that I'm interested in is in this term as well as in this term. These two terms have to stay on one side. This one does not belong with them. It has to go to the other side. So let's do that. So secant squared y plus 12 x squared y to the third factored out dy over dx. I cannot add them, but I can factor out what they have in common. Equals 8x cubed but minus 6xy to the fourth. Can anyone give us the final form for dy over dx? This is our variable. This is the right-hand side, and this is the factor in front of this variable.
That would be 8x cubed minus 6xy to the power 4 over secant squared y plus 12x squared y to the power 3.
Brilliant. Thank you very much. Awesome. Great job. That's it. So now you can say, and I will agree with you, what have you accomplished? You got the derivative, but it's still a function of y that you don't have. True. So this exercise is telling us that we can still find an expression for the derivative, indeed function of y. So what's the use of this? Well, I can still determine, if you give me a point, x equals a and y equals b, I can plug it in and get a number. So I have this equation. If you give me a point, let's say point P with a comma b, that verifies the equation. Otherwise, it's not on the graph of this equation, or conic section, or whatever it is, right? It's not a function. So if you give me a point, then I can give you the number that is the instantaneous rate of change of that equation at this point, or the instantaneous rate of change of y, that function, at this point, and I can give you a number. So that's the use of this. Now the floor is open for examples. If I find my book, if I go to 3.5, okay. So we can choose anything you want. Find dy over dx by implicit differentiation. One thing I wanted to mention. What's wrong with this notation? Nothing. Nothing is wrong with this notation. But when you see such a complicated expression, if you have y prime here and y prime here, you may accidentally omit or don't see the prime. And then the whole thing will be messed up. So this notation is kind of a, a straw in the eye. So you can miss this. That's why we don't want to use this notation in something like this. Can you use it? Yes. Will you get full credit if it's correct? Yes. I don't recommend it. It's very easy to omit this by mistake, and the whole thing will collapse from here. So please use this notation. It's wiser to use this notation versus this. Nothing wrong with that, though. Okay, back to our examples. So let's take a look. Anything you'd like to pick for finding implicitly the derivative of y, and then finding implicitly and determining the equation of the tangent, of course, over and over, or just determining the slope, whatever they're asking.
Could we try something like 5?
Yes. So we have x squared minus 4xy plus y squared equals 4. And we're asked to find dy over dx. Please use this notation. Nothing wrong with the other one, as I mentioned several times already. There is nothing we can do. We cannot solve for this. We could, because it's quadratic, we could, but it will be in terms of x. It will be a difficult expression. So all we need to do is just remember to differentiate both sides. Can anyone help with x squared?
2x.
Sure, of course. Minus. Put parentheses so we don't forget to distribute. The first function prime.
Would that be 4?
4 times the second function plus 4x times the second function prime. The second function prime.
dy over dx.
Thank you very much. Plus y squared, so close the parenthesis. Now, y squared prime
That's 2y.
times the inner function prime. I will probably have to ask everyone to say those words to me, so we never forget that. Times the inner function prime. Okay, what got stuck?
Is it dy over dx?
Dy over dx. 4 prime.
0.
Perfect. I have to distribute first. So then I get 2x minus 4y minus 4x dy over dx plus 2y dy over dx equals 0. These can stay, but these have to go to the other side. And I have to factor out this factor. This was negative 4x. When I took it to the other side, it becomes 4x. This was positive 2y. When I take it to the other side, it becomes negative 2y. Now I'm ready to solve for dy over dx. What will that be? Can anyone give us dy over dx?
So would that be a fraction? Like our final answer would be
Absolutely.
4x? So final answer would be 4x minus 2y.
This
no, I'm sorry.
Yes, yes. This multiplies, so it has to be in the denominator.
Right, and the numerator would be 2x minus 4y.
Brilliant. That's it. Thank you. That's
And
absolutely
you could simplify that, right?
no,
Or no?
but only by 2.
Yeah, by 2.
Yes. So you can factor out the 2 and factor out the 2 and then simplify. Let's do that. But nothing else. I'm not saying you said something else. I'm just making sure. So x minus 2y over 2, 2x minus y. This is the only thing we can do. The rest has to stay.